Okay. So each unique categorical variable will get a binary variable. So here is an example. Suppose we have a variable for employment status, right? So it has 4 values: student, unemployed, employed, and retired. So you will have 4 dummy variables for each one, each possible value. Student dummy variable will be 1 or 0, unemployed 1 or 0, employed 1 or 0, retired 1 or 0. So one variable with 4 values now becomes 4 variables. So you take that one variable out and put 4 variables in its place. Okay, so which is what we want to do. And here is the caveat: when modeling, we'll need only k minus 1 dummy variables, because if you know the value of, okay, when you have 4 possible values, if you know the value of 3 of them, then you can predict, you can correctly identify what the value of the 4th variable will be. So for example, if the first 3 dummy variables are 0, then you know that person must be retired, because that's the only left out value. The left out value can be easily identified. So if you have k possible categories, you can define k dummy variables, but you need only k minus 1 of them in the analysis. Okay. So you must keep that in mind. And how do we create dummy variables? That is, the code for creating dummy variables is model.matrix. So what model.matrix will do is it will create a matrix, and it will create a matrix with all the numerical variables as is. It's not going to do anything to the numerical variables. Whatever numerical variables in the data frame, it will just go into the matrix as columns. But if you have a categorical variable, then the categorical variable will be converted into dummy variables. Okay, remember how many dummy variables? If you have 5 categories, you will have 5 dummy variables for that one variable. If you have only 2 possible values, you will have 2 dummy variables, and so on. Okay. So let's run that code. Okay. So now what I want to do is to model.matrix, okay, housing.df. Right. Now let's save that into housing.mat. Okay. So that will be a matrix. So if you look here, it will tell you what kind of data structure you will have. What did I do? Okay. Model matrix is not that simple. So you have to, I forgot about that for a minute. Okay, you guys pay attention here. That's not good. Okay, so model matrix, you have to specify a model there. Okay, and the model can be like a regression analysis type model. Okay, so you specify what the target variable is. Okay, so suppose if you say total dot value, but well, first, yeah. Okay, so you need to give data. Okay, so data will be like that, which is the second item. So this is the data, and here is the model that we want. Okay, and the model goes like this. Okay, so you have a tilde. Okay, to the left of tilde is your target. Okay, on the right of tilde. Okay, well, you have the list of variables. You can specify what the list of variables that needs to be considered for the conversion. So you don't have to do the whole thing, right? So here we don't have a target variable, so we just say 0. Okay. So the tilde goes before that. Okay. And then you say plus and a dot. The dot stands for everything. We are not selecting some, we are just including everything in it. Okay. So this is the formula that we need, and data is that, then you run that, then so here is the large matrix. Okay, so you have the column names, and you see at the end the fireplace has become 2 because there are 2 possible values, 0 or 1, and the remodel has become, must be 3, old, recent, and none. So none, that's somewhere, I guess. Yeah. All right, we need to stop here, and we will review this again on Tuesday next week.